Recording. Okay, let's talk about Chapter 2, IA 201, Motors Controls. We're going to talk about Chapter 2, which is where we dive into symbols and diagrams. So let me just pause for 1 second. Some of you guys are going to be now learning about PLCs. And you're going to see diagrams in your programming class for the PLC programming class that are slightly similar to, but different from the diagrams we're learning here. We are learning about diagrams for electrical wiring, right? So you want to make sure that when you write down a diagram for electrical wiring diagram, you don't use symbols from your PLC programming class. So I will just throw that out there. Most of you guys are taking PLC programming or have taken it recently. A couple of you guys haven't, a couple of you folk have not, and that's fine, but just do not confuse the two. Wiring diagrams are one thing, PLC programming, even if it does look similar, is something else. So in Chapter 2, once again, this should be review. You have to understand how circuits work on paper. You need to be able to document what you see in the real world so that you can repair it and replace components and put them back the way they belong. You also need to be able to read the diagrams, potentially build circuits yourself. And that's actually a lot of what this course is going to be about. So in this book, it takes you through a lot of these diagrams. And these are all electrical diagrams. They show you a battery, long, short, with a positive and negative terminal, right? It shows you a AC source, which is basically, it could be a power source from the wall, or it could be a generator, a circle with a little squiggle in it, and so on, and so on, and so on. Each one of these has very particular meaning. I'm going to highlight a couple of them that are really important and maybe slightly confusing. Number one, switches. Switches are shown usually in a circuit. They usually show that in a circuit. They just showed you little circles here. But in a circuit, you'll see a line coming out of the circle for the rest of the circuit. And a normally open switch, you're going to see a little line, usually below the two circles, with a little bit of an operator on there. This is on page 40. If you can't see it on your screen, then please turn to page 40. I'm about a little lower than midway down on the right side. A normally open switch is just a little line below two little circles. And if it's a normally closed switch, we show it closed. We have also different kinds of switches. You have held closed versus held open kind of switch. Right. Contactors are shown as a little open space between two little lines. The idea is you can, if you want to see electricity flow, you put a contact across, you put a little piece of copper plate across those two contacts, and then electricity can flow down that wire. A motor starter is the same as a contactor. This is showing 3 different wires because the motor starter they're showing is for a 3-phase motor. So it needs 3 different wires. And it's showing you the contacts, and it's showing you the overload connections. These little question marks upside down and backwards against each other are called overloads. It's very important to know what that symbol is. That means when you have too much current flowing through that wire, then they will pop open and disconnect those. You basically disconnect that wire in that circuit. So I'm not going to take you through all these diagrams, but you should be able to find this page 40, 41, and 42 and rapidly figure out what these different diagrams mean. And this is not the bulk of it. Here in the back of the book, we also have a lot of other places to look up wiring information. So don't forget, we got a lot of stuff in the back of the book. Definitions, lookup pages. Here on this appendix, on page 731, we see standard industrial electrical symbols as well. So, for instance, input coils, output coils, limit switches, things like that. All of this information is in the appendix, all the way to page 734, from 730 to 734. Okay. So what's here at the front of the book is definitely not all there is out there. The book also talks about different kinds of wiring diagrams. Your basic wiring diagram doesn't have any standardized format to how you lay it out. You lay it out based on what's convenient to show the different symbols, to see the different flow through the circuit. And when I say wiring diagram, I mean your standard schematics. They just show a simple flow. So your standard schematic is your basic wiring diagram, and that just shows all your components. There's no particular magic to how they're laid out on the page. On page 44, we get into line diagrams. And you can read about that. We also talk about ladder diagrams. A ladder diagram is laid out generically, especially when you have logic circuits in electrical circuits. So you've got your L1 or your high voltage or your 24 volts on the left, and L2 or your 0 volts or your minus on the right. And then you just show all the things that are hooked up between those two power sources, basically between the L1 and L2 or whatever, right? The ladder diagram is an electrical diagram. It's actually the origin of the electrical diagram that's used in PLC programming, but don't get confused by that. We want to use electrical symbols, not PLC programming symbols. We also have block diagrams, which show basically how major components are connected in relation to each other. Useless for wiring anything up. It helps you only understand how a system works conceptually. And we have flowcharts. Flowcharts are used for a variety of purposes. They're not used for electrical wiring at all. They're used for troubleshooting or explaining how you set up a PLC program process and so forth. So flowcharts are a general purpose tool for programming or for management. Why does the book glom them all together? I'm not entirely sure, but they're all together. The book also starts talking about electrical circuits and gives you good examples of basic electrical circuits. So read through these examples. It talks about control circuits. This is where we get to the core of this course, how we turn things on and off and why. So read through the different examples, take a look at the various example drawings here. And it starts diving into magnetic control circuits, which is a generic way of describing stuff you turn on and off with solenoids. A solenoid is nothing more than an electromagnet that you turn on or off to open and close a switch or a valve of some sort. And they are probably the single most important, traditionally, component for turning things on and off. Now, once we get into some of the modern circuits, we use electronics to do this, but there's so much solenoid work out there. You have to understand how a solenoid works. So this chapter takes you through some of the basics of how you turn it off, on and off a magnet, which could be relatively light, relatively low voltage and current to turn it on and off, to open and close a switch that could run something much bigger. And they take you through your first motor starter circuit. Very important that you read through and understand how this works. And let me just highlight one thing here for you. Here on this page 53, it takes you through how a motor starter circuit works. They show you a couple of different diagrams. They show you a line diagram in a ladder format for how the starter, basically the relatively low voltage stuff to control the magnetic coil that turns on and off that heavy duty starter. And then over here, they show you the heavy duty wiring diagram where these contacts are closed by that little coil there. We know that they're connected because they're labeled that way. We use M1 and we see these contacts are labeled M. So that when I energize that coil, it closes these contacts, and then we can run current down through these wires to the load. In this case, the load is a big three-phase motor. Right, and so you have to understand that these two work together. Now, just to add confusion, they give you a pictorial diagram of what all this stuff is. So they show you the same basically transformer there in place, connected up to a picture of your motor starter, hooked to a picture of your various push buttons. So this pictorial diagram is useless, or mostly useless, when it comes to wiring, but will help you figure out where to wire in the various things onto that physical contactor. If you pick up that contactor, try to figure out where to wire things in. These little pictorial diagrams are very useful for beginners to find where different stuff, where you wire in different things on a typical contactor. And there's a couple different contactors we're going to get into in this class. So this stuff is very important. You need to understand how these diagrams work and how to figure them out. Then they get into diagrams, which are much more complex, and they give you examples for troubleshooting using your multimeter. So very, very useful stuff.